Hey guys, it's Derek Winchester here with Mid Six. We have a special guest. It's Michael Dehaan, creator of Ansible. Michael, welcome. Thanks. Uh,
Yeah, thanks for having me.
can you give the folks quick introduction to yourself, and then also talk about Ansible. We can start there.
Yeah, sure. So I've been doing software stuff for a good while, and I guess one of my earlier programs was a data center management tool called Cobbler, which did a bunch of bare metal physical installs. Um, I did that while I was working for Red Hat. We built another tool called Funk, which was sort of about a kind of remote RPC call infrastructure. Um, and Ansible kind of started out as sort of a for multiple different reasons. I wanted to have another open source project, and I kind of missed having one at the time. But various places I went, I always kind of got thrown in with somebody trying to automate their server configurations and whatever. And Puppet had done a really good job of making CF Engine easier to use, but there were still some things that I wanted to try to improve on and do a little bit differently. Um, so Ansible kind of started out as an attempt to kind of do some of those things, and I'd thought about them quite a bit earlier, but just didn't have the time to start them. And as we started to build on that, a lot of people were saying, well, the idea of a configuration system that just uses SSH and is a little bit more less, I guess, less dogmatic about some of its theories, where you could, if you just want to run a script, you could just run a script, was appealing, and kind of took off from a lot of the sysadmins from the Cobbler community that were kind of looking for similar tools at the same time.
Let me ask you a question. You said Puppet, right? So, what are the shortfallings? Do you have any what are the shortfallings with Puppet? You have.
So, I mean, well, Puppet's a great program. I worked for them for a little while as a product manager. In fact, there were a couple of things I wanted to address with Puppet, right? So, as a public key pair cryptography system, and at least at the time, that was often a little bit sometimes hard to set up if your DNS wasn't quite right or your clocks weren't right. And it took me, sometimes it would take me a few days to get that wrangled out. But the other thing is that Puppet, and they reverse course on this, and now there's an implicit ordering in the system, but you have to be very specific about saying what the order of things run. So it was a lot of people had problems where they'd have to rerun configurations one or two times to get them to converge, as it were. And then just kind of like making something that was a little bit easier to use, that the configuration of the system looked a little bit less like programming, a little bit more like your grocery list. So that was what I was kind of shooting for. But another big thing was, at the time, I was working at this one shop, and they only had about 100 servers attached to like an F5 load balancer, and they were orchestrating their rolling updates very much by hand because there wasn't a tool to do that, and always making some errors along the way. And the reason for that is, like, tools like Puppet and CF Engine were very good about OS configuration, but people typically didn't deploy apps with them. They typically go with a tool like Capistrano, which I don't even know if anybody uses anymore. Or Fabric, right? So these tools on top of the configuration management system to do these deployments. So could we build one tool that could do configuration and deployment all in one pass, right? And to do that required something that could break out of that declarative model and just say, hey, I want to run some scripty one-off kind of thing, some very order-based, very specific steps. So I think it was successful at doing that.
So as far as easy, you mentioned Puppet, you mentioned obviously Ansible, and you didn't mention Terraform. What do you think from Terraform?
Right, so cloud configuration is important. So Ansible has some cloud modules. They were originally developed 2012, 2013 or something like that. A lot of good community development in supporting those. But in general, I think like the idea of a tool that's purpose-built to describe cloud topology is important. Ansible's cloud modules are very atomic, one piece at a time, and it doesn't have that overall intelligence about the cloud. But I still think there's an opportunity for us to do better, right? So we're still in the very early phases of figuring out what cloud configuration should look like, right? we don't really know what that perfect tool is going to be looking like, but I think we definitely need to iterate on that a few more times to get closer to making that easier, because cloud topologies with like subnets and bastion hosts and VPCs, and it's just getting more and more complex as we're taking these things that used to only be known by like data center techs, right? And now we're expecting everybody to understand these at a basic level, right? And that's a lot for people to be able to do. So how can we more easily take best practices, topologies, and make it easy for people to deploy those versus everybody trying to figure it out on their own through some kind of like sparse documentation and leaving a lot of security holes along the way, or forgetting about backups, or forgetting about multiple availability zones and things like that.
Okay.
So Michael, I have a question. Why do you think Ansible right now is widely adopted by the different communities, and especially the network engineering communities? What do you think it appealed to them right now, when they released it? So
yeah,
it's released.
So I haven't, like I said, I haven't been involved in the Ansible project exactly for several years, but when the networking stuff was starting to take off, I think the problem was that every vendor had something different, right? But there really weren't any good tools, and it was very common. Like I very briefly worked for Cisco. We were doing some OpenStack stuff, and we had a network tech on like every call, just waiting there in case we wanted to like reconfigure a subnet, and it was very expensive and wasteful. And the idea that somebody has to manually log in for you and run some commands and make sure it works is it was really interesting to me, because like software was trying to automate it and had done it so much earlier. I think there can still be better tools in networking too, right? So with what you see with the Ansible modules, they're mostly just taking variables and then they're calling functions, and variables and functions are easy, right? Whereas like Ansible was really designed around the idea of like a host loop. How do we do rolling updates? How do we manage the variance between those systems? And one of the other things I was struggling with too is that, to me anyway, networks are graphs. They aren't trees, right? So YAML naturally describes a tree. So anytime you see in these sort of languages where they try to reference other parts higher up in the config and they actually start to form graphs, they tend to get messy, right? So that's kind of why I'm speculating that other tools need to exist. And like with networking, one of the other challenges I think too is that you want to be able to assert that other parts of the configuration are working before you continue, because you have a unique capacity to break everything very, very hard, very fast, right? But in general, like I think what people see with Ansible is it's a way to write, not have to write code. They can just write YAML, and they can have variables, and they can call functions, right? So that's an interesting balance to avoid the I'm programming in YAML thing, right? But really, it should just be about, like, it was meant to be about, I want to write lists of resources and say these things should be true, and then make it really easy for people to add and go on.
You know what? Hey, you know what? Let me take, because what you keep saying and what I keep hearing is the perfect tool, right? And I don't even know what the perfect tool is, but going by Ansible, Puppet, Terraform, Cisco has some products out there as well. Right now, we're the perfect, well, the tools that are out there, kind of, for example, learning YAML, right? It takes us back to code. It takes us back to a command line driven type of tool. Whereas I look at some of the other app development and mostly the way people use their iPhones, smartphones, smart tablets is more graphical, right? And the reason why I mentioned that, I think there's going to be a time, and nobody's mentioned this yet, coming up where you have, all your cloud vendors, AWS, GCP, Azure. I don't want to forget Azure. I'm sure somebody's going to get mad that Azure was last, right? Azure, however you want to say it, right? but being able to construct and configure and manage using a smartphone or a tablet, graphically, it takes away a lot of learning curve. I mean, honestly, learning YAML, and I'm embarrassed to say this. YAML was probably more difficult for me to learn than it was Python because you know, I'm trying to.
There's people out there that are doing that though. You take like Anuta and you take Platform 9, and they put the front ends on, OpenStack and some of the other stuff, and put them into nice graphical pieces that allow you to do just that. Now, I mean, the thing that I see that's missing from a lot of these tools is the closed loop to the automation, right? So where's the validation? Where's the check that says I'm out of policy or I'm in policy? And how do I maintain that and keep that CI/CD going, right?
Yeah.
So on the network side, we're missing that.
It's the idea of at least having something in version control, I think, is the most important point. Like, a lot of people focus on the infrastructure as code. I think if I had to do Ansible again, it would be probably completely code based, right? Because I think there's value in variables and there's value in type checking. And YAML came out in Ansible because I started it as a solo project, and I knew how much time Puppet spent writing the parser, and I was like, I don't want to write a parser, right? So that's what like, you can see the value immediately of having, like, this code needs to generate this thing, right? But the one thing that you don't get from that approach is, like, once you have everything checked in, you can at least see here's a branch, here's somebody who's signed off on this, the ability to review that change, right? And that may be sometimes hard to visualize, but if it is visualizable in that diff, that's kind of what people want to get across, right? So, I mean, I see the value of trying to keep those in text configurations, but it doesn't always work, right? And then a lot of that times that stuff can be very low level and you can't really spot the error, whereas like a tool that is providing something higher level has a chance to, and that kind of goes back to what I was saying with the cloud config, right? If I can say, have an abstraction around, give me a public private subnet and bastion host and all these other things versus having to specify 15 different cloud resources, right? I'm more likely to get that correct. So I would rather frameworks be opinionated, I guess, maybe.
But Michael, will that, because currently the Ansible is text-based, is more of a, that I think it's maybe the reason that many of the network engineers right now are adopting it, because it's a more easier to learn. It's not easier to learn in the essence of, I need to learn YAML, but at least there is a structured way of doing it. There is a text-based, it's not a code-based. So it might be easier to maybe get familiar with the text structure itself. Would you think if you rebuild it with a code base, will that be difficult to learn, or not? It's not about difficulty, but about the learning curve itself.
Yeah, so I mean, that's an interesting question. So I mean, I think one of the classic problems that you see in some of the modules today, right, is that they take very large dictionaries, and you have to know what every value is, and your editor isn't going to be able to provide like context-sensitive help of like, these are the parameters this takes, right? And you might be able to get that if it was like a Python class. So in the other thing that comes up a lot is lots of Ansible modules end up forked where people want to modify them to do something else, right? So in a world where people are going to learn Python anyway, maybe we should just go ahead.
Michael, you just made a statement. You just made a very controversial statement right there. In a world where people are going to have to learn Python anyway. Why do you think that?
Well, I mean, I just like every module in a lot of, it's like, so maybe 300 of your automation modules work perfectly, but you need to modify 2 of them, right? That's a scenario that's common, and it may just be a small thing like, I want this to work with a different version of this API, right? So I think one of the things that we got out of the whole, I mean, it's difficult, nobody knows what the word DevOps actually means because it's been repurposed thousands of times, but what we saw in about 2005, 2006, 2007, whatever, right, was people that were normally running operations by hand are moving closer to trying to automate them somehow. And then that gave the chance for a lot of like classical ops guys to learn Ruby and learn Python and stuff like that. So maybe things will move that way. I mean, I think we've seen a blurring of the lines where developers are expected to know more about their operation stack, and that's good. They understand more about how their code runs in production. And I think that's happening from the other side of the equation as well. It's not to say that there can't be text-based configuration for things and domain-specific languages and whatever, but I don't know. Python's hit a nice sweet spot. It's tricky. It could be more expressive, but the fact that it's not expressive makes it generally easier to read. Like, people don't have as many different styles between them, and it's kind of appealing because you can't get too clever, right? So that's definitely been, I think, probably one of the key reasons for the uptake.
I think that the sets of verbs that you have to work with are a lot smaller than other languages too, and that makes it a lot easier to kind of incorporate, especially for network engineers, right? This is kind of new to us. Some longer. I mean, we've been expect scripts or TCL or something, right? So still the basic logic, but this real drive because is all due to complexity for us. The order of magnitude to make a change in the network now is so much more. So it needs to be precision based. So I think it's kind of the feast or famine kind of thing for a lot of network engineers, and I think Python just happened to be like the current thing that was out and easiest to learn.
Yeah, there's definitely been a lot of people that were like flirting with Go and Rust, but they're just such like low-level languages that it takes so much work to do basic things. I think you lose the productivity. So they've got a very nice sweet spot between this is a prototype, I've written it, and then this is actually maintainable. So like you don't actually need to go back and re-overhaul things. So
well, network engineering specifically, it went through a very long period. And now this is where I make everyone sound old in this call, right? Went through a very long period where organizations, enterprises didn't want development done. They didn't want the supportability, the nightmare, right, of being able to support this stuff, right? And in the 90s, and before that, there was a lot of that in mainframes and so forth. But at least for the longest period, network engineering is not. So now we're in starting an era of programmability. Which is why I kind of, so for a lot of people, that especially people are listening to this, Python is that's the only language they know or they're even aware of, right? So that's why I stopped you to talk about that. And Ansible pretty much is the only other tool that's being pushed to them. So, it's great that you came on board and kind of explain all that. But what's next, Michael? What do you think is next in the line for automation tools?
Well, I mean, so that's a tricky one, right? So, I mean, part of me feels that most of it's done and it's good enough, but there's some interesting currents running around in that. I'm not a giant container fan, right? But everyone wants to seem to containerize the world. And that's caused some interesting pressures on the automation market, right? So, or the classical config tools such as like CF Engine and Puppet, Chef and Ansible, right? To me, I see them going in two directions. They're increasingly used to deploy some private cloud kind of thing, right? And they're being used to applied to networking, right? Because I think they're trying to pivot, right? And that's okay. And what people are doing in the automation world is, and it's going very slowly because not everything fits this way, but people are more and more adopting like the idea of immutable systems. And this is a pre-container idea, but I want to bake an image. I want to deploy an image. When the next version of the app comes along, I'm going to blow away these instances and get some new VMs, right? So that is the way the market has been going since like 2014, but it's really 2013, really. But it's been going really slowly, right? And I think like Docker and other things have increased that push. But along the way, what we've seen the tools to manage these container fleets are very, very immature and very, very complicated to manage. So you see that what it's actually doing is giving people kind of I guess the analogy is it's not better, it's different, right? You've got a new set of management challenges and a new set of complexities rather than sticking with the old thing. So we're kind of like rearranging the deck chairs, and now we have to figure out how to automate the new thing. when we could have possibly settled in and said, hey, we've already figured out how to automate all this stuff. Let's just write some software for our business, right? But that's not happening right now. There's a little bit of stuff going on with, I guess, in like the monitoring log analysis world, but it seems like it's kind of the same thing. It's just like we're now respinning monitoring as observability. We're respinning log file and aggregation as like artificial intelligence or something like that, right?
Speaking of AI, I mean, do you think there's a role for that along with like machine learning in that? A change gets pushed out, like this firewall change or this server gets built, this gets executed. Well, now I've got 5,000 new blocks and firewall, and our business critical applications went down, right? That's where, at least in my mind, we're good at automating the initial configuration and who approved what along the lines. But after that gets rolled out, we can roll it back easily, but figuring out what exactly the change need to be made to get the business back to where it is.
Yeah, I don't know. I'm not really up to speed on all the fancy neural net AI technology at all. I'm kind of a little bit of a skeptic. I think in many cases you could write an expert system that said between these two events, all these things changed, right? And it's one of these things versus like get some system to magically figure it out. So I haven't been like sold on any of that yet. But I can sort of understand why it might be appealing.
Maybe
everybody. Right now, the current buzz is machine learning. So no matter what product you have out there, let's throw some machine learning in there and juice it up. I'm sorry, Abdel. Go ahead.
No, I'm just saying when you have numerous data sets, you need to make like sometimes you will try to find the meaning of and insights from those data sets. Anyway, so that's why the buzz now of machine learning data science. When you have or any form of visualizing data in a way to drive insights from. But the idea is in network provisioning, what would a machine learning algorithm will do? In my mind is trying to be more intelligent in telling the user that maybe configuring this CLI or this part of the network proved to be make the network unstable based on previous cases of configuration. And I think that would be very lucrative use case for tech, for example, or for any organization who will do troubleshooting or will do some sort of managed service provider business model. When they mass provisioning a network with settings that might not be optimum or need to be fine-tuned because of previous because it learned from previous trouble tickets or attack engines. That might be a use case. And I think Cisco Tech is utilizing part of that, but it's not in that story I'm actually telling. So
yeah, I don't have anything that does this, but I've got a project on the side that's doing some Git source code analytics for other reasons. And I had a discussion with a friend of mine who was basically saying kind of the same thing: is could we if we put all our alerts back into the source code database, can we tell that changing this file is dangerous, right? Or this person changing this kind of thing is usually dangerous. Or these files have changed since the last alert, right? And I think like trying to get those data sources together could be really interesting. Yes.
If you have a large customer base like Cisco and you can gather the information from them and put them together back into such a database, that could be quite valuable. Mm-hmm.
The algorithms might actually be pretty simple. It's just like between here, if every like you kind of get a plus or minus score, kind of like in hockey, every time your file has been that close to an outage.
Yeah.
Well, Cisco actually does use it. They started using it on their attack cases as well as the well, most of you guys are now don't see this, but when you open tag cases, they have a chatbot which actually tries to guess what to do next and so forth. So, but like we saw in a whole bunch of other implementations out there for machine learning, it suggests what to do next. DNA has mechanisms to suggest what action to take. But when you start looking at, okay, I want something to be more automated, take the action, and then let me know later. It's hard to find a use case that it just, it's looking at all three dimensions of a decision-making process. I was.
Some companies out there are doing it. Like, I know, my leadership in their former lives at Visa, did a lot of, reactive case handling with, ticket systems, and then triaging and building in some of that intelligence. It's far from an exact science, but they were learning based on ServiceNow tickets and resolution codes, and keeping a database that they were able to handle a certain percentage and offload that from the service desk.
Well, I think the challenge is in the pivoting on the fly, right? And all the different permutations of, well, if we make this change here automatically, what's the dominoes that could fall? And then going back and choosing the right one so all the dominoes don't fall. There's
actually, sorry.
I was going to go is that there's interesting things going on, and then also the human factor to being, approving the risk, right, on the fly. There's some interesting things going on in the contact center using AI, like companies like Observe.ai that's using voice inflection within a support call to actually tell if people are kind of annoyed or kind of what, to kind of alert the agent to kind of treat them differently and pivot within the event, right?
Yeah, I mean, think of it, it's a scary thing, right? In the networking, IDS, IPS, right? So having that device automatically start shunning traffic was a scary thing to people. So that, that just kind of silent change and notify only that's a leap for a lot of organizations to assume that as the normal operation.